All right, so for our first problem, we had our two functions, f of x, x squared minus 3, and g of x was the square root of x plus 3. All right, so, I mean, one thing you could say to yourself is, first, does it look like the inverse? Okay, well, on one, we're squaring x and then subtracting 3. On the other, we're adding 3 and then taking the square root. So far, it sounds like we're doing opposite operations, okay? But we have to check. So again, the way we check is we do composite functions. So first, I'm going to do f of g of x. So that means I'm taking my f function and I'm plugging in the square root of x plus 3. So again, this x plus 3 is going where this x is. So I'm going to have, I'll put it in parentheses, square root of x plus 3. Okay, so then what am I doing to that? I'm squaring it and then subtracting 3. So here, right, the first thing we do to this is we square it. Well, a square and a square root cancel each other out. So then we're left with x plus 3 minus 3. And what do you know? Those cancel out, and we're left with x. So far, so good. We got half of our problem solved. Now, we have to make sure it's true for the opposite. Okay, remember, these both have to equal x. Okay, so I'm plugging my expression x squared minus 3 into my g function now. So just be careful here, because you're going to have the square root of the whole thing, x squared minus 3 plus 3. So because these are both underneath, and this is just addition, I can drop the parentheses, and minus 3 plus 3 gets me 0. So I'm left with the square root of x squared. So that does equal x. I'm going to talk about this in a little bit because that kind of gives us something interesting. But for now, that's good. All right, so the first one we do get, yes, they are inverse of each other. Okay, so we can call one of these f negative 1. All right, for our second one, that was number 1. All right, we have f of x is 2x minus 5, and g of x is 1/2 x plus 5. Another way you can write this, okay, if you wanted to, is you could say x over 2. So again, just taking a look, right? Here we have x, we're multiplying by 2 and then subtracting 5. Here we have x, we're dividing by 2 and adding 5. So, you know, logically, we're doing opposite operations. But again, let's just double check to make sure. So doing f of g of x, okay, so I'm plugging in my g function into here. So we're going to have 2, okay, because right, that 2 is on the outside. And then I'm replacing x with x over 2 plus 5 minus 5. All right, make sure this whole expression goes in there. So first thing I have to do is I have to distribute this 2. So when I do that, well, they cancel out. I don't want to cancel that out, though. So I have x. Then I have 2 times positive 5. So that's plus 10 minus 5. So I'm left with x plus 5. So right away, I don't have x. So I don't even have to do the second one. And I can say that they're not inverse of each other because I didn't get x as my solution. All right, so the first one, they were inverse, and the second one, they were not. Any questions about that or the homework or anything there?
I was confused on the homework. I was so confused, but now it's better.
Okay, yeah, a little better understanding now.
Yeah.
Okay, all right, and if we need to, we can come back for anything. Okay, let me just. All right, so today. hmm, We're going to talk about finding the inverse function. Okay, so the first thing that we have to kind of consider is that not all functions have an inverse. So the way we first figure out if it does have an inverse is we have to figure out if our function is what we call one-to-one. Okay, so I'll give you the formal definition and then we'll expand on that. Okay, so the formal definition of a one-to-one function is a function is one-to-one if each value of the dependent variable corresponds to exactly one value of the independent variable. Okay, an easier way to say that is every y value has exactly one x value. All right, so I'll leave that there for you for a second if you need to copy that. So, like in the beginning of the year, when we had is it a function or not, right? And that was that we had to make sure that every x only had one y. So now we're doing the reverse. Now we're making sure every y only has one x. So just like before, we can implement a test. Okay, but now we're going to call it the horizontal line test. All right, so let's take a look at some graphs first, and then we'll keep talking about it. All right, so if we're talking about a basic x to the third function, okay, what I do is I draw horizontal lines. They're not exactly horizontal, but you get the idea. And here we can see that it crosses only once. Okay, so here, my y value of -8, the only answer that I'm going to get -8 with is if I plug in a -2. Okay, if my answer is -1, the only thing I can plug in, the only independent variable I can plug in is -1. Okay, so those are 1 to 1. Now, if I had something like x squared, and I do the horizontal line test, it crosses twice. Okay, and again, if I look at this, right, I have 2 squared equals 4, and I have -2 squared equals 4. So here, I have 2 separate x values that give me the same y value. Now, again, this is kind of a special case because for, like, we do technically have an inverse to x squared, right? We square root. But remember, if I want to, algebraically, if I'm solving, something like x squared equals 2, to solve this, we take the square root. But what we technically have to do is we have to add the plus or minus in front. Okay, so that tells us we're not 1 to 1. Okay, some other functions that are not 1 to 1, okay, are our trig functions. All right, so what we do is when we're talking about the inverse of these, we have to be very specific and talk about intervals. We're going to get into some of that stuff later, though, but just know that these aren't 1 to 1. So if your function is not 1 to 1, you cannot find an inverse. It does not have an inverse. All right, so that's the start of it. So now we'll talk about actually finding the inverse. So I'm going to give you some steps first, and then we'll take a look at an example. All right, well, the first thing is okay, the first thing is make sure it is 1 to 1. All right, so again, you can graph it out, and you can use the horizontal line test. Okay, the second one, okay, the second thing is if we're given the function in function notation, we want to change that f of x to y. All right, and that's that's a rule. Right, that's a kind of known fact that f of x equals y, so you can change those out, and you don't have to worry about messing around with the function. So this is where we actually start doing stuff. Right. The next thing we're going to do is anywhere we see an x, we're going to replace it with a y. And anywhere we see a y, we're going to do the opposite and replace it with the x. Okay, so this is our first big part. Then, after we do that, we're going to isolate the y. We're going to solve for y. Okay, once we get the y by itself, we're going to substitute in our inverse notation, f -1 of x. And then technically in math, you're always supposed to by doing our rule that we did yesterday. All right, so I'll give you some time to write down those 6 steps, and then we'll take a look at an example and talk about it. So I'll give you a minute to finish copying that down. All right, we good, or do you need some more time? I'll take your silence as we're good. Okay. So we'll start off easy. Yeah, we got 10 minutes. We're good. All right. All right. So first thing we're going to do is find the inverse of f of x equals the square root of 2x minus 3. All right. So the first thing you're going to do, like I said, is we're going to check that as 1 to 1. All right. So you punch it into your graphing calculator or whatever you got. All right. And we get this function here. Now, if I did a horizontal line test, it increases, but it never looks like we have, like a parabola. We won't see anything else on this side. It's not going to come back down. Okay, so it is 1 to 1. I can keep going this way, right? And every y value only has one x value assigned to it. Let me go all the way back. Okay, you can see it goes on forever that way. All right, so that's good. We're 1 to 1, so that's a check. So our first criteria is satisfied. So then we're going to go to our second step. All right, let me see, make sure. Okay, we're in function notation. So I'm going to change that to y equals the square root of 2x minus 3. Okay, that was our second step. So first step, second step. Our third step is to swap x's and y's. So this is a y, so I'm going to change it to x. This is an x, so I'm going to change it to y. Now that we have everything swapped, we're going to start isolating this y. I want to get this y all by itself. So remember, when we're solving for something like this, when we're isolating a variable, we want to work from the outside in. Okay, I can't get rid of this 3. I can't get rid of this 2 until I deal with what's on the outside of this. So the first thing I have to get rid of is the square root. Okay, in order to get rid of the square root, we're going to square both sides. So on my left, I have x squared. On my right, I'm just left with 2y minus 3. Again, working from the outside in, I'm going to add 3 to both sides. So we have x squared plus 3 equals 2y. I only have one more thing to get rid of, and that's that 2. Because we're multiplying, I'm going to get rid of it by dividing. Now, me personally, I would leave it as one large fraction like this. You could also split it up, and you could write it x squared over 2 plus 3/2. All right, but here you're dealing with some fractions. I think that looks a little neater. It's up to you. I would accept both answers correct. All right, we have the y isolated now, so I'm going to check. I'm going to replace the y with f negative 1. And we have our final inverse function. Okay, I'm going to, like I said, technically our last step is we have to confirm. So you would plug this in here, right? The square root would cancel out with the square. The 3's would cancel out, and then you'd have 2x over 2, and that would give us x, right? And then again, if I took this and I plugged it in here, the 2's would cancel out first, the 3's would cancel out, and then we'd have the square root of x squared, which again would leave us with x. All right, just because we're running a little short on time, I'm going to skip the last part. Okay, any questions about that? So what I will do, though, is I'm going to graph it. So we have x squared plus 3 over 2. So I'm going to make a new function. X, oh, I can't see that. Oh, x squared plus 3 over 2. Okay, so this is where I was talking about the x squared. So here we only look at the positive. Okay, so if I just look at the positive values, okay, we said yesterday that should be a reflection of that one, right? And they should be reflected over the line y equals x. Well, here's my line of reflection, this blue line, and yeah, it looks like the green line is a pretty good reflection of the red line. Okay, but again, like I said before, this is a special case because we have to kind of ignore what's going on over here. All right, so that's that. Actually, you know what? We're gonna leave it off here today. The next example is a little more complicated, and I don't want to go over our time together. So you'll have one question tonight that'll be like a check your understanding. It'll be pretty simple, and then we'll get into some more complex problems tomorrow. Any questions?
No.
Okay.